Hello all. Today I'm going to talk about section 2.1 quadratic function. Let's first start with the definition. A quadratic function is a function that looks like this. F of x is equal to ax squared plus bx plus c, where a, b, c's are coefficient, or in short we call them numbers. Coefficients. And of course x are the variables. Okay? Among the coefficient a, b, and c, the number a is called the leading coefficient. We have a condition for coefficient a. A needs to be non-zero. See why? If a is equal to 0, then the x squared term will be vanished, disappear. Then you don't have quadratic function anymore. We only have bx plus c, which is a linear function. That's why we need condition of a to be non-zero. An example of quadratic function. Say f of x is equal to 3x squared minus 2x plus 5. And in this particular example, a is 3, b is negative 2, and c is 5. All right? Next, I'm going to go over some basic properties of quadratic functions. So, properties. Let's start with the first property, the graph of it. The graph of a quadratic function is so-called a parabola. It looks like a letter U. Could be upward or it could be downward. Depends on the leading coefficient a. If a is a positive number, then the parabola is upward. If a is a negative number, then the parabola is downward. Second property, number 2. We're going to talk about the vertex. You see denoted by the letter V, H, comma, K. Vertex is a very special point on the parabola. This is like the top or the bottom of the parabola, depends. If the parabola is upward, the vertex is the lowest point on the parabola. If it's downward, then the vertex is the top of the parabola. Okay? And since it's a point on the plane, we denote it by VHK, where H represents the x coordinate and K is the y coordinate. So in general, if you are given a quadratic function, f of x equal to ax plus ax squared, plus bx plus c, then you will be able to find the vertex of that parabola, regardless of the orientation, whether it's upward or downward. And the formula is this. H is negative b over 2a. Remember, the a is non-zero, so it's okay for us to take negative b divided by 2a. And then after you have h already, you can calculate k by plugging an h into the function. It's f of h, which is f of negative b over 2a. Let's start with an example. Say, example, f of x is equal to x squared, say minus 4x plus 3. In this particular example, a is 1, b is negative 4, and c is 3. And of course, a is a positive number, 1. We know that this parabola will be upward. So the vertex is the lowest point, or the minimum of that function. All right? And we can use a formula to find the vertex. H, which is the x coordinate, is negative b over 2a. In this particular example, b is negative 4, so negative of negative 4 over 2 times 1, which is 4 over 2, equal to 2. After you have h ready, you're going to plug h into the function. Calculate k is f of 2, which is 2 squared minus 4 times 2 plus 3. We have 4 minus 8 plus 3. 4 minus is negative 4 plus 3 is negative 1. So the vertex is at 2 comma negative 1. Okay, that's the second property of quadratic function. We know the graph going to be parabola either upward or downward, and the lowest point or the highest point, called the vertex, is calculated with the formula. All right, let's move on to the third property, number 3. Thing called the axis of symmetry. Let me show you the parabola again. This is upward parabola, and this is the downward parabola. The parabola has a very special properties. The graph will always symmetrical about this vertical line, and this is called the axis of symmetry. This axis of symmetry is actually a vertical line that will always go through the vertex, okay? And the vertex, as you know already, the coordinates of vertex is h comma k. Therefore, the equation for that vertical line is going to be x equal to a constant, and this particular constant is going to be h, which is negative a over 2a. And this applies to both cases, either upward or downward. Parabola doesn't matter, it's going to have the same equation for the axis of symmetry. And this is the third property. Next property is property number 4. We're going to be talking about how about the domain and the range of the quadratic function. Domain and range. Whenever you guys hear about the domain, you think about the x, which is the input. What value can we plug into the function? And for the range, you think about the output, or the y value. After we plug in the x, what should we get out? Okay? And we're going to learn about the domain and range of quadratic function via graph, by observation. Okay? So basically, we have two types of parabolas. Start with the upward one first. Parabola right here. We know this is a vertex, so it's going to be h here, k there. This is the x-axis, y-axis. Origin is right here. For the x value, we're kind of tracing along the graph. It can move freely all the way from the left to the right. But the domain is going to be all the way from negative infinity to positive infinity. And the range is going to be the y values up and down. It can go up forever. It's not going to go down forever. Stop at y equals to k right here. And it's including k. So we're going to use square bracket. This one is from k to positive infinity. Similarly, we have other type of parabola, which is upside down. And of course, the vertex is right here, h. I'm sorry, that's h. And this is k. So the domain is same thing, negative to positive infinity. But the range now is not from k to infinity anymore. It's go down forever. Go up to k. So we're going to write this way. Negative infinity with parentheses. And then k in square bracket. Okay. That's the fourth property of quadratic function. I'm going to give you one more. Let's talk about the intercept. Five intercepts. intercept is a point where the graph intersects the x-axis of the y-axis, as you see right here. See the graph intersect the x-axis or the y-axis. Let's start with the y-intercept. So y-intercept is a point where the graph intersects the y-axis. So any point on the y-axis is going to have x-coordinate equal to 0. So in order for us to find the y-intercept, you can let x equal to 0, then calculate y, or solve for y. Okay? By the way, y here means f of x. So if you have the equations like f of x equal to, say, ax squared plus bx plus c, let me write it this way, and instead of writing f of x, let me write y equal to ax squared plus bx plus c. Your y means f of x in here. And you plug in x equal to 0, you're going to have y equal to a times 0 squared plus b times 0 plus c, obviously is equal to c. So the y-intercept is 0 comma c. Of course here 0 means the x-coordinate is equal to 0 and the y-coordinate is equal to c. Okay? The second type of intercept is the x-intercept. The x-intercept. Similar to the y-intercept, you want to find the x-intercept, which is on the x-axis. We're going to let y equal to 0. And solve for x. So from here, if you let y equal to 0, you're going to have what? 0 is equal to ax squared plus bx plus c. Now we're going to have a quadratic equation. All right? Ax squared plus bx plus c. Everything one side equal to 0 on the other side. We call it a quadratic equation. And we have a very famous formula to solve a quadratic equation, which is called the quadratic formula. And the quadratic formula is x equal to negative b plus or minus square root of b squared minus 4ac all over 2a. All right. Question: how many intercepts we may have with the quadratic equation or quadratic function? Let's start with the y-intercept. You see, it doesn't matter if it's upward or downward parabola. It doesn't matter how you draw it eventually. The parabola will intersect the y-axis. It's exactly 1 point. So for sure, you will always have exactly one y-intercept. Okay? What about the x-intercept? We have several cases in here. You see, in this particular example, the parabola is completely above the x-axis. We have no x-intercept at all. What if we kind of shift the graph down a little? What if the graph is this way? It's touching the x-axis. Then we're going to have exactly one x-intercept. And you know what that point is? That point is the vertex of the parabola. And what if the graph is down a little bit more? And it's going to intersect the x-axis of 2 points. We're going to have two x-intercepts. And the number of the x-intercepts really depends on this quantity right here. And we even have a name for it. It's called the discriminant. People used to denote it with Greek letters called delta. It's triangle. It's like b squared minus 4ac. Okay? You see, if this delta is a negative number, say negative 5, negative 4, you take square root of a negative number, you have no real solution. We have no x-intercept at all. Okay? If delta is negative, no real solution. This means no x-intercept. What if delta is equal to 0? Now the whole thing right here equal to 0, so that radicals is cancel out. You got negative b over 2a. Sound familiar? Negative b over 2a is the x-coordinate of the vertex. It's the point right there. We have one real solution, So we have one x-intercept. Okay? And then the last case, if delta is a positive number. So you have positive numbers, square root of positive numbers, say square root of 9 is 3, and then plus or minus, we're going to give you two solutions. So 2 solutions. And that means you guys are going to have 2 x-intercept. Okay? Those are the basic properties about the quadratic function. Next, I'm going to talk about another form of quadratic function. The form that we've been learning so far is called the general form. It's the form that we use for definition, general form. F of x equal to ax squared plus bx plus c. Okay? Now I'm going to show you another form called I usually call the vertex form. Our book, I think they call it standard form. So let's call it standard form. So item number 3, standard form. Okay? The standard form of quadratic equation will look like this. F of x is equal to a times x minus h squared plus k. And here a is the same as the a in the general form is the leading coefficient. And they satisfy the same condition. A needs to be non-zero. Because if a equals 0, then it's not quadratic anymore. Okay? What about h and k? We actually talked about h and k already, where h and k will be the 2 coordinates of the vertex. Alright? That's why we usually call it a vertex form. But I'll use the terminology that the book uses. Standard form. Okay? Let's give example. Example. F of x equal to 3 times x minus 2 squared plus 5. In this particular example, a is equal to 3, which means the leading coefficient is 3, which is a positive number. You know that parabola will be upward. And x minus h plus k, so h is 2 and k is 5, and that means the vertex is at 2, 5. Alright, so you know the vertex and you know the leading coefficient right away by looking at the quadratic function. How about another example? Say f of x is equal to negative of x plus 1 squared plus 4. We don't see a number right here, but negative right here means as a is negative 1, which is a negative number. You know, parabola is upside down. And what about this? X is minus h, right? This plus 1 means what? Minus negative 1. So h is negative 1 and k is 4. So the vertex is at negative 1, 4. Okay. There's one type of exercise you may see in this section is how to convert back and forth between the general form and the standard form. So let me give you an example. Say f of x, make it easy one, okay? Use the same one as before. X squared minus 4x plus 3. I'm giving you the general form. And I want to rewrite the quadratic function in this vertex form or the standard form. And how can I do? The standard form is this. This is general form. Okay, I want to change to standard. Standard will look like this. F of x equal to a x minus h squared plus k. So I will jump to figure out a, h, and k. By looking at the general form, I know for sure that a is equal to 1. Okay? What about h and k? Well, we have a formula to find the vertex. H is actually the x-coordinate of the vertex. And we know that h is negative a over 2a. So it's negative of negative 4 over 2 times 1, and that's equal to 2 already. And we calculated before, just rewrite it. And after having h, calculate k, which is f of 2, which is 2 squared minus 4 times 2 plus 3, and of course it's negative 1. So you know h and k, you can write the form. F of x is equal to 1 times x minus 2 squared, and then minus 1. That will be your standard form. There is actually another way to convert from general form to standard form called completeness square. Well, I'm going to cover that topic later on. Alright, what about the other way around? Say you have a standard form. Can you bring it back to general form? Of course, you can do that too. It just factor out, I think. Say f of x equal to x minus 2 squared minus 1. Just kind of FOIL that thing out. Then combine the line terms, bring it back to the general form. X minus 2 times x minus 2, and then minus 1. X times x is x squared. X times negative 2 is negative 2x. Negative 2x, negative